Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam online classes. Today we will have a new topic which is very interesting, and all of you also will join with us, and I hope all your petrol tank is full, right? Petrol tank means what? Breakfast or lunch or snacks. Okay, you are fresh, right? Okay, you brought your book and pen. So nice. And the topic is about surface areas and volumes of solid figures. So before you come to this, you should know some of the basic things about this, about what is called as plane figures. Plane figures like square. You heard about square? What is speciality? It has got a length and breadth, right? Both are equal. Rectangle, it has length and breadth different. All the angles are 90 degrees, right? Circles also, you have seen all these things, and they are called as plane figures. Why they are called plane figures? Because they can be drawn on the board or on the book. Or in other words, you can say they are two-dimensional figures which have length and breadth or radius, etc. And hence they will have areas and perimeters. What is perimeter? Perimeter is a total length. See, suppose this is a rectangle, it has got two lengths and two breadths. Sum of these two is called as perimeter. What is area? Area means the region covered by that figure. So these are things which you already seen in your classes earlier, is it not? Also you know about objects which have definite shape and size are called solids. Solids. Solid means strong. For example, cube, cuboid, cylinder, cone, sphere, etc. Then you may ask, where do you get all these things? We will show it now one by one. And all these, solid objects having definite shape and size are called as solids. And they will have areas also. They will have volumes also. When you say area, it has got lateral surface area and total surface area. And volumes also. That you have studied in your previous classes, some basic thing about it. And also you have understood the meaning of surface area and volume of solids. Suppose you want to paint the walls of a room. How many know painting? Oh, most of you know it, right? You can try in your home, with permission of course. Take guidance. While painting, you should know what is the length of the room, breadth of the room. In class 7th you have studied length and breadth of the walls also. And also volume of solid figures. I think some of you have experience of bringing milk from the society. When you measure the milk or water or any oil, you measure the volume, right? We say 1 liter. 1 liter means how much? 1000 ml. Is it not? Half liter means 500 ml. Like that we measure. So, similarly in case of bricks and all, It has got length, breadth, height and all. So all these basic things you have studied in your previous class. And also, equations of one or two variables. Equations of one variable. What are they called? They are called simple equations. Or you can say linear equations. Simple equations are those which have only one variable. So like this, x plus 3 is equal to 6. What is the value of x? X is 6 minus 3. Plus 3 will be brought this side. It becomes minus. Or it may be p minus 6 is equal to 7. What is the value of p? Minus 6 should be brought here. 6 plus 7 becomes 13. Or it may be 3m equals 12. What is the value of m? M is 12 by 3, 4. Is it not? Or you can say a by 5 is equal to 4. What is the value of a? A is equal to 5 into 4, 20. So these are all called simple equations having one variable. That also you have studied in the previous class. Also, equations having two variables. They are also called simultaneous equations. Suppose you have x plus y is equal to 5, x minus y is equal to 1. Come on, anybody? Value of x? Yes, it is 3 and 2. So 3 plus 2 is equal to 5. 3 minus 2 is equal to 1. Is it not? So they are called equations of two variables. So all these things you have studied in the previous class. Now what is that you are going to study now? That is very interesting. Before you come to that, we will list out some objects of daily life, what you see. For example, all of your house will have a bricks. When they build the walls, they use bricks, right? You can have hollow brick, cement blocks, or red color bricks, and so on. And almirah will be there. Every house will have almirah. And the shape is called cuboid. Is it not? And you have seen die that is used for snake and ladder games. And even for other games also use die. Tea packets. The shape is called cube. Even you might have seen some candies coming. That is also cubic in shape. Is it what is called halkova? That is made up of sugar and some flour. That is also cubical in shape. Even sugar, crystals of sugar. Sugar also is cubical in shape. And then you have drums and powder tin, etc. It is a cylindrical shape. Even pipes will be there. Pipes. Is it not? So different, especially so many of you are farmers' children. You know how the pipes are used in the farming work. All these, they are cylindrical in shape. Then you have joker's cap. In circus, they use a cap. You might have heard about Santa Claus. Santa Claus, that shape is called conical. Even ice cream cone. When I say ice cream, most of your mouth will get saliva, right? Okay, you will get it. Ice cream cone. Can you tell some more example? Yes, wicket caps. Caps of wicket. How many play cricket? Raise your hands. Super. So that cap of the wicket is also cone in shape. So many things are there. Even there is a Christmas tree. Of course, you cannot measure it, the length and breadth and all, but the shape is conical. and football. TT ball. TT ball is a perfect example of a sphere. Table tennis ball. Even your cricket ball also. So cricket ball is also a very good example of. Even there are some chocolates. The chocolates will be there inside the ball. You have seen it? If you remove the cap, the chocolates will be got. They are all spherical in shape. And also, if the sphere is cut off into two, you get a hemisphere. Even the tennis ball, if it is cut, it becomes hemisphere, right? So these are some of the objects what you see in daily life. Even there also you can make a big list. You try yourself, make a list of your articles what you see, but they should have some shape and size. You should not say stone. Stone has no proper shape, is it not? There is no proper shape. Such things, tree you cannot say. Even though it is solid, you cannot say because there is no proper shape for that. Tree, hillock, all those things. But we are listing out those who have proper size and shape. Now you want to see this once again in real. So are those especially village boys and girls who have not seen these things can see once now. You have vision now. Is it nice? Okay. Whatever you told now, you can see here. This is called bricks. The wall is made up of bricks here. This is Almira. And these are cuboids. And this also cuboid. Your book also is cuboid. Trunk is cuboid. And this is hemisphere. The bowl is a hemisphere. This is football. This is a sphere. This is cylinder. This also is cylinder. Bottle. And this is what you call bass drum. That may be cylinder shape. Is it not? This is cone ice cream. That is a conical shape. Even the joker's cap. These are some of the examples of daily life. Is it not? So you can go on listing out. So very happy. I think you enjoyed all these things in your daily life. And we have seen about perimeter. The boundary of a triangle or a rectangle is called perimeter. So the sum of the length is called perimeter. And area means the measure of the plane region enclosed is called as area. For example, the board is here. The length and breadth. This is called area. Is it not? Perimeter means what? Two lengths. One length here, one length here. One breadth here, one breadth there. So two breadths and two lengths become perimeter. So this is already studied. Surface area of a solid figure is the area of the surface or boundary constituting the solid. It is measured in square units. That is important. In such problems, you must write a centimeter square or meter square, etc. Square units. And what about volume? Volume is measured in terms of cubical units. The measure of the space region enclosed by a solid figure is called volume. It is measured in cubical units. Say centimeter cube or meter cube, etc., etc. So space region. For example, your classroom is there. Classroom has a length, it has a breadth, it has a height. So when you say volume of the air inside is L into B into H, isn't it? That is how you measure it. And now you should know the purpose. For doing everything, you should know purpose, why you are doing it. Suppose you ask, why should you play? What do you say? Sir, we want to enjoy. We want to get more energy. You want to forget all the daily tensions. That's why you play, no? Why you eat? To get more energy to become strong. Why you sleep? To relax. Forget all that plus and minus of a day. Why do you pray? To get the grace of God, like that, no? So also we must know, why should we know the area and volume of the solids? So for example, for whitewashing of the walls, painting of the walls, or to put some papers, color papers on the walls, and ceiling of a room, to paint the surfaces, we have to find the surface area. Is it not? So also volume. If you enter to storing some milk or water, some vessel is there. You should know the volume of that vessel. To store liquids or some food grains in a godown, how much bags can be stored in that godown? For that you must know the volume of the godown. Is it not? What is godown? Godown is a big storehouse of the grains, right? So, coming to cubes and cuboids. So here, this cube, see, this is a cuboid. Cuboid will have a length. This is called length of the cuboid. And this is called the breadth of the cuboid. This is called the h, height of the cuboid. That's how a cuboid is made. Okay. So it has got length, breadth and height. And this is how it is made. You can take rectangles, 6 rectangles, and fold it in such a way that it comes in shape of a cuboid, right? And it can be easily seen from the figure that a cuboid has 6 rectangular regions. So for example, this is a cuboid. Can you see it? Yes. It has got a length here, breadth here, and height here. L, B, H. So also here. Followed. It has got 6 surfaces, 2 length and breadth, 2 length and height, 2 breadth and height. Okay. So this is the cuboid. So we say that AB, see here, AB. AB, see here, AB from here to here, that is called length, is equal to EF. This is EF from here to here. Is equal to CD. This is CD. Is equal to GH. All these are called length. All these are called length. Okay. Then you have breadth. AE. AE is the breadth. This is the breadth. And then EH. AE is equal to BF. This is breadth. Then you have CG. This also breadth. Then you have DH. Followed. Then AD is called height. AD, this is height. And this also is height. This also is height. This also is height. All these are called heights, right? So AD, this is AD, then EH, then BC, then FG. All these are called height of the cuboid. Now diagonals. Diagonals are EC, AG, BH and FD. See FD. This you join it, it becomes diagonal. So join this FD, it becomes diagonal. And one more is EC. EC. If you join this EC diagonal, then AG, AG, A is here, G is here. To avoid confusion, I don't write now. You can draw yourself. BH, B is here, H is here. Join this, it becomes diagonal. Lastly, FD. This is F, this is D. Join that, that will be diagonal. So there will be 4 diagonals of a cuboid. Okay. So that is all about the different parts of the cuboid. Now, what about surface area? 2 into LB. LB means length into breadth. BH means breadth into height. LH means length into height. These are the explanations. So much of square units. Volume of a cuboid, L into B into H, cubic units. Okay. Then you have diagonal of a cuboid, root of L square plus B square plus H square. Followed? Where L is the length, B is the breadth, H is the height. Okay. So please bear it in mind. 5 times you must tell and write and practice. Okay. Then only it will be there in head. Now here is a question. Find the surface area of a cuboid with the length L is equal to 4 centimeters, breadth is equal to, so you are given with the length L is equal to 4 centimeters. Breadth B is equal to 3 centimeters. And height H is equal to 12 centimeters. What is the area? So, surface area of a cuboid, we call it as TSA. Today or later, so total surface area of a cuboid is equal to 2 into LB plus BH plus LH. That will be equal to 2 into LB. L is 4, B is 3, 4 into 3, 12. BH, 3 into 12, 36. LH, 12 into 4, 48. So add all that. So this will be 48 plus 48, 96. So 2 into 96. That will be equal to 2 6 are 12, 2 9s are 18 plus 1, 192. So much of square centimeters. That is the total surface area. We call it as TSA. TSA of cuboid. Then you have volume. Volume is equal to V. L, B, H. What is L? L is 4, B is 3, H is 12. So 4 3s are 12, 12 12s are 144. So much of centimeter cube or cubic centimeters. Coming to diagonal. Diagonal of a cuboid is equal to root of, come on, L square plus B square plus H square. Done it? Come on, do with me. You must be faster than me. Okay? So, root of L square. L is a 4 square. 4 square is 16. B is 3. 3 square is 9. H 12. 12 square. 12 square is 144. That is 25 plus 144. 169. Root of 169 is 13 centimeters. So 3 marks question. How many can do it? Oh, most of you. Very good. So this is surface area 192 square centimeters. Volume 144 centimeter cube. Diagonal is 13 centimeters. Understood? Okay. Find the surface area and volume of a cuboid of length 6 meters, breadth 3 meters and height 2.5 meters. Here meters are given. Find the length of the longest rod that can be put in the room of dimension 6m into 4 meters into 3 meters. So longest rod means you must find the diagonal. Okay. So let us see what Bhagwan Baba says. Bear all and do nothing. Whatever comes now, should bear it. Maybe good sometimes, maybe bad sometimes. Should bear it. Hear all and say nothing. So many people will telling so many things. Hear them. But don't give your comments on that. Give all. Go on giving. Take nothing. Hand must be like this. Not like this. Okay. Serve all and be nothing. So go on serving people without any pomp or show. Okay. That's what Baba says. And I hope all of you will get ready with the homework. Thank you.